Hi, Erin.
Alrighty then. I guess we must have been on page 409. 409. Yes, we had just filled in these 5 commandments of particle motion. We're talking about velocity, and if you move left and right, velocity was negative, velocity was positive, all that stuff. So now we're going to go to a problem. And that's why I said I hoped that all this stuff would make more sense when we did an example. So we're going to suppose the velocity of a particle is given by, and then they give us some equation. T is in minutes, V of t is inches per minute, and we're going to answer the questions. A, find the values of V of 3 and V prime of 3, and then describe the speed. Okay, so V of 3 would mean the velocity of 3, or velocity of the object at 3. And here's the formula. So we just plug in 3. 3 plus 2 plus 4. Yes.
Whenever there's an exponent on the parentheses, do you distribute the exponent, or do you do the parentheses and then an exponent?
Do the parentheses first.
Okay.
Yeah, good question. So we have 5 times 7 squared.
I know PEMDAS, but I couldn't remember if you distributed it.
Right, no, I get you. No, you do the parentheses first. So 49 times 5. We got 245. That would be inches per minute. And then we're supposed to do V prime of 3. So it might help to do V prime of t first. V prime of t is the same thing as acceleration. So the derivative of the first is 1 times the second, because you got to do the product rule, plus the first times the derivative of the second, which would be 2 times t plus 4 to the first, and then times the derivative of what's inside, which is just 1. I could go ahead and simplify it, but I'm just going to plug in a number, so there's no real reason to. That's good. So then we plug in 3. So 7 squared plus 2 times 5 times 3 plus 4 is 7. So 49 plus 7. And 19. Yep. And since this is acceleration, it's inches per minute squared. And then it says describe the speed. So yesterday we talked about speed. Remember, if the signs of velocity and acceleration are the same, then the speed is increasing. So notice both of these are positive, so the speed is increasing. Put that over here. Speed is increasing at t equals 3 minutes because V of 3 and A of 3 are greater than 0. Okay. Does that make sense? Yeah. So But because they are the same, they're both positive, it's increasing. If they're both negative, it would be increasing as well. But if they were opposite, then it'd be decreasing. Okay. On what interval is the particle moving to the left, right? Show your analysis and justify your answer. Okay, so according to 1 and 2, if the velocity is positive, then it's moving to the right. And if the velocity is negative, then the object is moving to the left. So they gave us velocity. They gave us the equation for that. It was t plus 2 and t plus 4 squared. Okay, so we're going to set that equal to 0. Basically, it's like we're finding maxes and mins, but this is already the derivative because this is the velocity. So if you set t plus 2 equals 0 and t plus 4 squared equals to 0, you get at t equals negative 2 and t equals negative 4. And this only makes sense for this problem as velocity. Time, here it is. Time can only be greater than or equal to 0. Here's our number line. So when t is only greater than or equal to 0, so can't really have t equaling negative. So let's just, if at any point greater than 0, which we've already done the one that was t equals 3. When I plug in any number greater than 0, I get a positive. And I only did t equals 3 because we've already done that one. So on the interval 0 to infinity, v of t is greater than 0. So, say that again? You can include, yes, you should include the 0. So the object, whatever it is moving right basically all the time from 0 to infinity because it's always positive. This is a sample free response question. It's modified a little bit just because at the time everything it asked for we couldn't do yet. But so the graph of velocity in feet per second of a car traveling on a straight road, 0 to 50, is shown below. And a table, 5-second intervals, is also shown. So we've got a graph, and we've got a table of data for us. And this is velocity. All right. A is during what intervals of time is the acceleration of the car positive? Give a reason for your answer. So acceleration is, of course, the derivative of velocity. So we look at the graph or we look at the table, and we're going to find where v of t has got a positive slope or increasing. So how we can describe this is if a of t is greater than 0, then v of t must be increasing. Which occurs on, okay, so let's look at our graph. Let's see. So increasing means we're going to have a positive slope. I basically have a positive slope everywhere except here. That looks like it's really the only place. That's where it's decreasing. Everywhere else it's increasing. So that must occur then on 0 to 35, and right here should be 45 to 50. We could have also gotten that from our table. We can see all of these are increasing up until I get to 35, and then from 35 to 45 it decreases, but then it starts increasing again. So we can either get that from the table or from the picture. Okay. B, find the average acceleration of the car over the interval.